Hi guys, welcome to the channel. So today we are gonna see one more problem from array. So that is the easy level problem. So that is basically the majority element 169. So let's understand the problem. So we have given one array of size n and the majority element will be appearing n by 2 times. It appears more than n by 2 times. So there must always be an majority element existed. So that is not the assumption that is given in the question. So let's say for this example, if you see this is the array and it stores 3 to 3. So if you see 2 is coming as one time and 3 is coming as two times. So if you try to calculate n by 2, so n by 2 will be 1. So 3 is coming as more than n by 2, it's 2 times. So output is 3. Now let's say for this example, so if you see 2 is coming as 1, 2, 3, and 4 times, and then 1 is coming only 3 times. So 2 is coming as 4 times. That means if you calculate the size of the array 1, 2, 3, 4, 5, 6, 7, 7 divided by 2, so 3, and the 2 is coming as more than 3 times, that is the 4 times. So that is the solution. So 2 is the solution. So let's understand very basic uh, let's understand very basic solution of this question. So let's go to the problem. So let me copy this array and then let me paste it over here. Right. Okay, so this is the array basically, right? So let me draw the array. So we have the array that is basically 2, 2, 1, 1, 1, 2, 2, right? So this is the array. Now the first approach basically here, if you approach 1. Now for this one, let's see how we can do this problem with the approach 1. So let's just see this one with the brute force. So in brute force, what we will do, we'll start the count from 1, and then what we'll do, we'll check from this element. So 2 is equal to 2, then our count will be 2, and then 2 is checked with this one. So it's not equal 2 is not equal to 1, so the count will be same. 2 is checked with this one, and then 2 is checked with this one, and then 2 is checked with this one, so count will be 3, and then 2 is checked with 3 with this one, the count will be 4, right? So in this case 2 is coming as 4 times, so we will store this one, and then the same thing we'll do it for this one, for this one, for this one, for this one. So for this one, if you see how much complexity that will be. So first is that to traverse the array and then compare each element with all of the array. So that will be order of n square. That is the first approach. So in the order of n square approach, we can actually solve the problem and then we'll get the output. But that is not the optimized solution. So the other approach, we have the other approach as well. So we have approach 2. So in this approach, basically what we are going to do, we'll use the hash map. So how we can use the hash map? So let me quickly draw it. So our array was 2 2 1 1 1 2 2. So what we will do, we'll traverse it from here and then we'll store the element. Let's say 2, and then count is 1. It's again 2. So what we will do, we'll put it as 2 and then 1. So we'll store 1 and then count 1, and then 1 is coming again. So what we will do, we will increment its count, then 1 is coming again, then what we'll do, we will increment its count, and then 2. So the 2 count will be 3, and then 2 again, then the count will increase by 1. So 4, and this is the hash map, and then we'll see if the if this is the count matches with the n by 2, then what we'll do, we'll try to return it. So in our case, 1 2 3 4 5 6 7. So 7 divided by 2 equals to 3. So basically we are taking the lower value, and then 4 is greater than this, so we'll return this value, and then 2 is our candidate. So this is the approach 2. So we have one more approach, which is approach 3, right? So that will be approach 3. So in this approach, what will happen, basically we are gonna use the Moore's algorithm. So in this approach, basically we will take two variable and then we'll keep on incrementing the count. If that is the same, if the element is matched with the previous element, if not, then we will keep on decreasing the count by one. So let me quickly write the algorithm and then we can see over there. Okay, so yeah, I have written the code of the Morse algorithm. So let me quickly explain you the code. So first we'll declare the count and the element. Both will be 0 0. Then we will traverse our loop from, like, we this is there we are using the for each. So we'll traverse the loop. We'll check count equals to 0. If yes, then we will just assign the num to the element, and then again we'll check num equals to element. If both are same, then we'll increment the count. If both are not same, then we will just decrement the count. So here we'll take two variable basically. So so first is count equal to 0, and then element also equals to 0. Now let's traverse it. So it will traverse. Let me quickly take the array as well. So 2 2 1 1 1 2 2 2 2 1 1 1 2 2. So our array was this 2 2 1 1 1 2 2, right? So this was the array. Now at first it will start the counter from 0. It will check if count equals to 0. Yes, count is equal to 0. Let me put it over here. Let me remove it and let me put it over here. Count equals to 0, and then element equals to 0. So first it will traverse it from here. So 2, if count equals to 0, yes, then element will be num. So element will be 2. So I'm over here. So element will be updated to 2, and then it will check if num equals to element. So 2 equals to element, yes. So in this case count will be 1. Now it will traverse it from here. We are over here. So it will check count equals to 0, no. Then it will check if num equals to element. So 2 equals to element, yes. So it will, what it will do, it will increment the count to 1. Now we are over here. It will check if count equals to 0, no. Then it will check num equals to element. So our num is 1, and then element equals to 0. Element is 2. So 1 equals to no. In this case count will be decremented by 1. So count will be 1. So we come over here. It will check count equals to 0. No, count is 1. Then it will check 1 equals to element 2. That is no. So what it will do, it will decrement the count by 1. So again the count will be 0. We'll come over here. It will check if count equals to 0. Yes, count is equals to 0. So what it will do, it will it will it will update the element to num. So our element will be num 1, and then it will check num equals to elements. Yes, 1 equals to 1, yes. So what it will do, it will increase the count by 1. So we'll come over here, and then it will check if count equals to 0. No, count is 1. It won't execute this if. And then it will check num equals to element. So our num is 2, and then element is 1. So 2 not equal to 1. So what it will do, it will decrement the counter to 0. And then at the last, it will come, it will check if count equals to 0. Yes, count is equal to 0. Then in this case it will do element equals to num. So element will be updated to num. Num is what, 2. And then it will check if num equals to element. Num is equals to, so 2 is equals to 2, yes. So what it will do, it will increment the count by 1. And then our loop will end in this. Whenever our loop will end, so whichever value is there in the element, that is the solution. So yeah, so we'll return 2 is our solution. Yeah, so I hope concept over here. So that is basically the Moore's algorithm. Yeah, so yeah, thanks for watching. See you in the next video.